Question 6, and we are given a curves equation. It's not clear looking at that what it will look like, but we don't need to worry about that. They've also given near the top of the screen a domain on which the curve is defined, x greater than 0. That's just so that we can, it's just their way of avoiding the fact that x cannot equal 0. It doesn't have a huge impact on this question, so don't really worry about that. Part A, we're dealing with this point P on the curve which has, and we're given the x coordinate, and it's saying find the tangent, and you should get that as your answer, y equals 1 minus 2x. Well, finding a tangent, that smells of differentiation, doesn't it? So let's differentiate. I'm first going to write the curve in index form, just that last term there. Let's write it as minus 8x to the power minus 1, and then dy dx easily calculated like so. We're interested in the gradient when x is 2, and if we work that out, we get negative 2. So we now have the x coordinate 2, the gradient minus 2. We still need the y coordinate when x is 2, so we have to substitute that in as well into the original y equation, and we get minus 3. So when you've got a point and a gradient, and you want to know the straight line that has those properties, or that has that gradient and goes through that point, you should use y minus y1 equals mx minus x1. You can write down y equals mx plus c, substitute and work out c, but as a little crude, I'd encourage you to use this tool here. So we substitute in our values. X1 and y1 is the point we've found. Minus 2 is the gradient for m. Rearrange, and we get the result as required. B, now we need to do the same but with a normal. So the only thing that's going to change here is the gradient, and it's going to be a negative reciprocal of the tangent's gradient. So minus 1 over negative 2 that we found before gives us a half. Same tool, we have the same point but a different gradient. That point there was 2 minus 3. Substitute in, and we get the result that we need for the normal. Now, for part C, you're given these facts about tangent at P has a root at A, and the normal at P has a root at B. Now we need to find those points. I'm just going to sketch some axes there, just for later. So the bottom left of the screen, you can see, let's just write down that equation there was the tangent, and that equation over there on the right was the normal. To find where that strikes the x-axis, set y to be 0 and we get a half, and for the normal, if you set y to be 0, we get x is 8. So I'm plotting those now in orange on the axes, and I'm going to plot also the point P, which is down there, and connect those 3 points up into a triangle, and then half base times height will give you half times 7.5 times, the height is 3, isn't it? If you depth really, but that'll do. 11.25 square units.